In 2016, two Orthodox Jewish girls went viral because of the following song.
Did Dor Yeshorim cause I got Dor Yeshorim cause I got Dor Yeshorim cause I did Dor Yeshorim. Hey, hey, my chassan did it too. Hey, hey, cause he's a good Jew.
At first, this song was sent around on WhatsApp chats, then it was posted to Facebook and YouTube, and before you know it, they had their own profile on Genius known as the Anonymous Beis Yaakov Girls. The organization that they're singing about is called Dor Yeshorim, which does genetic screening for Orthodox Jewish couples before they start dating. And so in this video, I want to unpack all of that. I want to talk about how the puzzle of inheritance was solved, how that led to genetic screening and the ethical questions that came along with that. But most importantly, I want to tell you the story of one man who turned his personal tragedy into a mission to help his community.
Okay, I did the Dor Yeshorim, yeshiva full of svarim. I visited some kfarim, even bought kol hane'orim, and shadchanim are calling. My bachrim always ballin'. My parents might be stalling, but come at me cause I'm all in. I've been starking, I've been shaving, pick me up, we're going dating. Dave and Buster's or a lobby, tell me all about your hobbies.
If you're new here, hi, my name is David, and here on Yiddishkeit, we talk about the experience of Jewishness. Personally, I like to do that by looking at Jewish history, culture, and art. To me, this story of Dor Yeshorim is interesting for a few reasons. First off, because it's about the Jewish community that I grew up in, but also because it has to do with science. I used to be a science teacher, and I taught high school biology for a few years. And in New York State, the ideas that you have to teach come from something called the learning standards. Call me crazy, but I'm someone that believes that in order for other people to find something interesting, you need to share something interesting about it. And so when it comes to the study of genetics, which is part of high school biology, I try to find the stories of how we as humans unlocked the secret to what was being stored inside our bodies. This is the story of how cells, genetics, and DNA were discovered. And it's really fascinating because not only did it change history, but it also explains how the natural world around us works, which is something that you learn about in high school. But I would also mention to my students this organization, Dor Yeshorim, because it was an example of how this information we were learning was actually applied in real life. In fact, I would pull up the genetics resource page on their website, and we would read it together and see that we actually understood what it was talking about because of what we were learning. In this video, I don't have any standards from the Department of Education, but I want to share with you these amazing stories of scientific discoveries and organizations which both left their marks on history. Our story begins in Buenos Aires, Argentina in 1965. A young man named Yosef Ekstein is waiting in the hospital while his wife is in the maternity ward giving birth. A few moments later, he meets his firstborn child, a beautiful baby boy. Yosef is from a Hasidic family from the Satmar community back in Hungary, and he had immigrated to Argentina when he was a child. Although he grew up hearing stories about how his family had escaped the horrors of the war and that he himself was born in a bombed-out building in Budapest, it all seemed very far away from him. He had grown up in peace, and later on as an adult became certified as a sheikhet, a kosher butcher, became ordained as a rabbi, and now he and his wife were hoping to build a family. At first, their baby seemed fine, but after a few months, things started to go wrong. He had a hard time swallowing and began regressing. And as they began to take him for a test, they noticed that he had developed these red spots on his eyes. And this was unmistakable. Unfortunately, their son had a disease called Tay-Sachs. Tay-Sachs is a horrible disease which causes the nerves and muscles to stop working, which leads to physical paralysis, the loss of sight and hearing, and complete mental disability. In 1881, an eye doctor in Britain named Warren Tay noticed these red spots in the eyes of people who have this disease. And a few years later, a neurologist in New York named Bernard Sachs described what was actually going wrong in the nerves and muscles. But he also noticed that this disease was hereditary, which means you didn't catch it like an infection, but rather it was passed from parent to child. Almost all of the children who are born with Tay-Sachs do not survive, and in the case of Rabbi Ekstein, his first child died at the age of 4. And over the next bunch of years, he and his wife would have 4 more children, only one of which was born without Tay-Sachs, which means that the other 3 children passed away. And so at this point, Yosef starts wondering, is there something wrong with him? Is there something wrong with his family? Why is he transmitting this disease to his children? It would take many more years and unfortunately more heartbreak before he would personally find this answer. And in 2011, Rabbi Ekstein was profiled by Mishpacha magazine, and he had the following to say about this extreme low point in his life. The Ribbono Shel Olam knew that it would take 4 children for me to get out of my own self-pity and turn my pain outward. I had 2 choices, despair or action. It took me nearly 20 years to get the message. Rabbi Ekstein was not the first person to ask these questions. In fact, for thousands of years, people have been asking, how are traits passed from parents to offspring? The first person to truly crack this code was a monk in the Austrian Empire named Gregor Mendel. And no, he was not Jewish. Turns out, not every guy named Mendel is Jewish. Mendel was obsessed with this question of heredity, and in the 1850s, he did a series of experiments with pea plants. I'm sure you know that as humans, we are sexual, which means that we have 2 parents, and that our traits are a mix of both of theirs. But what you may not know is that plants are sexual too. This means that they have 2 types of cells, the male cell, which is pollen, and the female cell, which receives the pollen. Mendel started collecting pollen and creating hybrids, which are mixes of green peas and yellow peas. And what he found was the following. I'm going to be using these gummy bears to represent the pea plants that Mendel used. So if you take a yellow pea plant and cross it with a green plant, in the first generation, all of the peas that are produced are going to be yellow. It's almost as if the green disappeared. But what Mendel noticed is that if you took 2 of those pea plants that were created and crossed them, in the second generation, around a quarter of the pea plants were green. In Mendel's day, in the mid-1800s, they didn't know what was actually storing the information that said a pea is green or yellow. But Mendel reasoned that since there were 2 parents, each plant got 2 copies of information, including about what color it should be. And that meant that there were 4 possible combinations. If I have 2 plants that have information for both green and yellow, they could produce one that's double yellow, one that has 1 yellow and 1 green from either parent, or a double green. As long as the plant had information for yellow, that was the color it would be, which means that that information was stronger, or what we call dominant, while the green information would remain hidden, which we call recessive. And so what we see is that when both parents have information for green that is hidden, there's a 25% chance that the offspring gets double green. This was the answer to the question of heredity. It explained why traits sometimes reappear in later generations, but it also explained how diseases like Tay-Sachs were transmitted. We can also represent this with a square, and we'll use a red gummy to represent Tay-Sachs and a purple gummy to represent healthy. If only one of the parents has this information for Tay-Sachs, then either the children get none of that information or only 1 copy, which means that they're not affected. This is because in order to have the disease, you need a double copy. And so if they only have 1, then they carry that information with them, but they're not actually sick. And this is called being a carrier. However, if both of the parents have the information for the disease, which is red, then there's a 25% chance that the child will get both copies of the disease, which means that this child will have Tay-Sachs and almost certainly not survive. Scientists started calling this unit of information a gene, which is similar to the word genesis, which means the origin, and that's because the origin of our traits comes from this information. As scientists were able to look deeper and deeper into our cells, they saw these thread-like structures, which we call chromosomes, and they contain these genes. But the one thing scientists couldn't answer was, how do genes actually store this information?
It's the famous light bulb going off story every school kid learns, how James Watson and Francis Crick discovered the structure of DNA and cemented their place in scientific history.
In 1953, two scientists in England went even deeper and figured out that the molecule storing this information is DNA, which famously has this double helix structure. This shape looks like a twisted ladder, and the key of their discovery is that the steps of the ladder, called bases, is what stores this information in a kind of code. There are 4 molecules that can be used to make these steps, and we refer to them by their first letters, so A, T, C, and G. And what happens is that A always matches with T, and C always with G. The hint I used to give was apples in the tree, cars in the garage. Shout out to the channel Amoeba Sisters, where I got that from. The point is, these steps allow a code to be stored in our genes. It can also be copied and used to make proteins, which are the tools in our cells, like enzymes. And if that code gets broken for whatever reason, the tools are not going to work, and at scale, the body is going to malfunction. So the obvious question was, can we look inside the cells of someone with Tay-Sachs to know what was going wrong? But the deeper question was, can we read that person's DNA to know what was going wrong with the code that caused this disease? In 1969, a Japanese scientist named Dr. Shintaro Okada and American scientist Dr. John O'Brien discovered that people who had Tay-Sachs were deficient in an enzyme called hexosaminidase A. And this is needed for the nerves to function, and therefore people who didn't have this enzyme would experience this intense disability, which was followed by death. And what they also found was that people who were carriers, who didn't have the disease themselves, had a reduced amount of this enzyme as well. And what this meant was that if you can figure out how to measure the enzyme levels in different people, you would be able to figure out who the carriers were, and more importantly, you can prevent them from having children with Tay-Sachs disease. On a rainy morning in May, 1,500 people gathered in Temple Beth El in Bethesda, Maryland, right outside of Washington, D.C. Dr. O'Brien, who discovered the link between Tay-Sachs disease and this enzyme deficiency, had been visiting Johns Hopkins University in Maryland, where he shared his findings with Dr. Michael Kabak. And Dr. Kabak was treating patients with Tay-Sachs at Johns Hopkins, and together with the parents of his patients and other community members, they launched the first mass screening for Tay-Sachs disease in 1971. And over the next few years, mass screenings in Jewish communities expanded across the country to communities in Philadelphia, Massachusetts, and California. And according to Dr. Kabak, by the year 2000, there was a 95% decrease in the amount of cases of Tay-Sachs in the Jewish population in North America. However, there was one type of Jewish community that did not see a reduction in the amount of cases, and these were the more Orthodox communities like Hasidish and Yeshivish. And the reason for this is that there were questions in halacha, which is Jewish ethics, about these genetic screeners. In fact, in 1973, Rabbi Moshe Feinstein published an open letter to his son-in-law where he talks about this question of whether or not people should screen for Tay-Sachs. In the letter, he talks about how he doesn't feel like people should screen for Tay-Sachs since knowing one's carrier status would cause an increased amount of stress and anxiety, which he calls nervin in Yiddish. He was also concerned that if people knew each other's carrier status, that this would create a kind of social stigma, which would make it harder for people to get married when the idea of genetic screeners was to make it easier. And in that letter, he writes, Shelachein tzarech hadavar liyos bitzina, v'lachein lo tov hadavar la'aseh b'kivatz rav, kimay b'yeshiva subate sefer v'chadaimen. What this means is that Rabbi Feinstein was against mass screenings, and if someone felt compelled to do a genetic screener, let's say they had a family history, then this should be done privately. In addition to this, Rabbi Feinstein also distances himself from the other Jewish genetic screening organizations across the country, since they would also screen women who were pregnant, and if the child was found to indeed have Tay-Sachs disease, they would recommend an abortion. As you probably imagine, abortions are not generally permitted in the Orthodox world. Yes, there are some exceptions, but as a general rule, this was not permitted. And so in practice, Orthodox communities just simply didn't participate in genetic screenings. And so it's into this climate where there's new technology, but also skepticism from halachic authorities that Rabbi Ekstein buries his fourth child. And it's at this point that he realizes that there has to be some way to bring genetic screeners to the Orthodox community in order to prevent other couples from going through the intense pain that he and his wife were going through over losing their children. In the Orthodox world, boys and girls are kept completely separate. They go to different schools. In synagogues, there's a partition between men and women, and there are no places where young men and women can get to know each other. As a result, young people in the Orthodox communities meet their partners in a system of arranged dating. So the way it works is that there's a marriage broker called a shadchan that keeps in touch with many families, and at one point they will recommend to the parents of two families that their children should meet. You might be familiar with this role from the famous musical Fiddler on the Roof, where we meet the marriage broker, Yenta.
Such diamonds, such jewels. I'll find a husband for every one of them.
In the secular world, the sequence of events looks something like this. People meet their potential partner, they form an emotional relationship, and then down the line, when things get serious, they decide to get married. However, in the Orthodox world, the order of events is reversed. First, people decide that they're going to get married, and only then do they start meeting other people and check if they are emotionally compatible. Today, arranged dating works in one of two ways. The first way is practiced in the Hasidic world, and it's called a bisho. You can see this depicted in the miniseries on Orthodox, where the main characters meet at this kind of date. This is usually held in one of the family's homes, where the young couple meets for only a few short times before deciding if they're going to get married to each other. The other way, which is practiced in the community I grew up in, the yeshivish world, is called a Shidduch date. You can see this portrayed in the Israeli show called Shababnikim, and it shows how the man and woman will meet for the first time almost always in a hotel lobby. And then after a few dates, they see if they're compatible, and then they begin the process of getting married. Now, if you haven't heard of this system of arranged dating, then it might come as a bit of a surprise to you, and you might have a similar reaction to the main character in the movie Crossing Delancey.
You made an appointment with a marriage broker? Rabbi, this is not the way I live. This is 100 years ago.
And so Rabbi Ekstein realizes that the Shidduch system would provide the perfect framework to introduce genetic screeners. And so he launches this program together with a doctor that treated his late child named Dr. Robert Desnick, who is the chairman of human genetics at Mount Sinai, together with two members of the Jewish community named Mr. Horowitz and Mr. Weiss. And they launched this organization called Dor Yeshorim, which loosely translates to mean healthy generations, and it's based on this verse in Psalms 112. And on the original logo, there's also the words in Hebrew, Mainea Dema'os, which means to prevent tears, which refers to Rabbi Ekstein's mission to prevent couples in the Orthodox world from having children with Tay-Sachs disease. So when it was first launched in 1983, only 45 people show up to that first event. The next year, they do a little bit better, and they have 175 people. But unlike the first genetic screeners for Jewish communities that started in the 70s in Maryland, Rabbi Ekstein had to swim against a decade of skepticism and reluctance in the Orthodox community. He needed to not only reassure people that he was acting within the bounds of halacha, Jewish law, and rabbinic authority, but what he really needed to do was to make this genetic screener feel like a seamless part of Orthodox life. The system was quite simple. People of marriageable age would donate their blood, which would be analyzed for the presence of hexasaminidase A. And instead of their names, they would be assigned a number under which their genetic records would be stored. And so when a shadchan proposes a match between two families, each of the families can call up this hotline number and supply both of the numbers for the boy and the girl. If only one of the two is a carrier for a disease, then they are told that they are compatible. But if both of them are carriers for a disease, then Dor Yeshorim does some further testing and provides genetic counseling, which means they inform the families of the risk of their children getting married to each other and would recommend against them going out on a first date. And this would prevent the anxiety of knowing one's carrier status, since most of the time, one of the two people in the match are not carriers, so they never end up knowing the exact details of their genetics. And since all of this is done with a number instead of a name, no one in the community could find out who the potential carriers are. And since all of this is provided only to people who are not yet married and don't know their carrier status, it also avoids abortion. It made so much sense that on Hanukkah in 1984, Rabbi Moshe Feinstein, who was once an outspoken skeptic of mass genetic screening in the Jewish community, writes a letter in support of this new organization called Dor Yeshorim. But the true success of this organization would happen when they would start collaborating with schools. They would come into senior high school classes for girls and into seminaries after high school for boys. They would give them a brief introduction into what it means to be a genetic carrier, and then they would do this blood test. In exchange, these students would receive a number which they would use as part of their Shidduch process. And today, Dor Yeshorim works in over 500 schools in America, Israel, and across the English-speaking world. And according to them, they get over 50,000 calls about compatibility each year. And in 2016, in one of those schools, two girls wrote and performed a song about this blood test, which they were about to do, that would be screened for genetic diseases like Tay-Sachs. And this would thrust them into internet virality. To Jewish people outside the Orthodox world, they found it interesting to see girls from such an insular world rapping and beatboxing, and in fact, this intrigue led to several articles in Jewish publications. If you look at the comments underneath the video, you'll see the debate from 9 years ago, where people were saying that this video should be taken down. For some, the reason was that the girls never agreed to be posted in the first place, and for others, the reason was that if this video stays up, then it will ruin the chances for these girls to find a match in the Shidduch system. 4 years earlier, in 2012, members of this community gathered 60,000 strong to publicly ban almost all use of the internet, except a few exceptions regarding work. So it makes sense that these high school girls having such a big internet presence all of a sudden could be perceived as a breach from the communal morality and would potentially reflect badly on them as a partner. Based on what I know, which admittedly is word of mouth, I know someone who knows them. They both seem to be happily married and gainfully employed, so I guess it all kind of worked out in the end. Today, the video is still up, but what I find really interesting is the impact that this song really had. For example, when I was preparing to make this video, I would mention that I was working on a story about Dor Yeshorim, and anyone that was around my age that went to high school in the 2010s would start doing the dance moves and singing the song. Did Dor Yeshorim cause I got Dor Yeshorim cause I did. Hey, my chosin did it too. Hey. So I guess what I'm saying is that just like the internet, this song is here to stay and has left an impact on an entire generation. But what I find really interesting about this song are the actual lyrics. The song opens with the girls explaining that they're about to do a blood test to screen their genetics, and that this is just a normal part of the dating process in the Orthodox world.
Doing this test to see if we're a match, and if it's a yes, well, I'm a really good catch.
Then the song goes on to detail how she and her future husband are living the Orthodox lifestyle, they have kids of their own, and when they come of age, they also do the Dor Yeshorim test. And then the song ends with this girl on her deathbed. No, I'm not making this up. And she's reflecting on her life, and she realizes how it was all enabled by Dor Yeshorim.
Now I'm lying in bed, hooked up to IVs, where I 120 zip past and breathe through the full life dedicated to Hashem. Thanks, Dor Yeshorim. This is the end.
To me, this song explains why Dor Yeshorim was so successful in the Orthodox world. Because it was tailor-made to fit the needs of the Shidduch system, it became just a part of dating as institutional as the marriage broker and the hotel lobby. This also explains why this system of confidential screening only works in the Orthodox world and is not scalable. As one researcher put it, attempts to generalize Dor Yeshorim's approach to the non-Orthodox communities have generally failed. Although Dor Yeshorim was founded to solve certain halachic questions around genetic screenings, as the technology got better, the way these screenings were done also changed. And this opened up a whole new set of questions, one that we're still dealing with today. And so although Dor Yeshorim was able to prevent thousands of children from being born with Tay-Sachs disease, screening people for their genetics also poses a potential danger of this knowledge being weaponized. And this is something that, unfortunately, Jewish people are all too familiar with. As the science of genetics developed in the mid-1800s, the idea that some traits were helpful for survival, while some weren't, further led to the idea that some genes were good and some were bad. We reference this idea all the time. Like, you'll hear people say, "You have your mother's eyes," or, "Oh, it runs in my family." Both of these are examples of referring to genetics as good or bad, respectively. Humans have been selecting for good and bad genes in plants and animals for thousands of years. This is the heart of agriculture. But when you start doing that for humans, it's known as eugenics. And let's just say it's a little bit more complicated. The most extreme case of eugenics as an obvious force for bad is in 1935, when the Nazi Party in Germany infamously enacted the Nuremberg Laws. This classified Jewish people as an inferior race who could no longer hold German citizenship or marry German people. The thing is that this law was enacted supposedly to preserve the hygiene of German genetics, but as we know, this would end in the death of millions of Jewish people across Europe. So here's the thing, selecting a partner based on traits that you like is technically a kind of eugenics, I guess, but I hope we can all agree that it's not the same thing as the eugenics of Nazi Germany. And in fact, recently you saw this tension kind of explode in regards to the marketing campaign for denim pants.
My jeans are blue.
Sydney Sweeney has great jeans.
So let me pose the question this way. On a scale from Sydney Sweeney to Nazi Germany, where does genetic screening land? When genetic screeners first started in the 1970s, a Jewish bioethicist named Dr. Fred Rosner wrote a paper called "To Screen or Not to Screen." In the paper, he expresses a concern that since Tay-Sachs disease disproportionately affects Ashkenazi Jews, that these new screeners could potentially be used to violate Jewish patients' rights. He describes how genetic screeners were once weaponized in the United States since sickle cell disease, which is also hereditary, disproportionately affects Black people. Many states had mandatory testing which was based on race, and this would down the line affect people's healthcare and in some cases their employment abilities. Although these laws were eventually found to be unconstitutional and later changed, Dr. Rosner worried about a genetic test that was specifically for Jews. But beyond those concerns of government overreach and discriminating against people based on their genetics, as the technology progressed, scientists were able to look deeper into the human DNA. This led to many more bioethical questions. The information for heredity is stored in these thread-like structures called chromosomes, which are made out of DNA. And as we were able to determine which chromosomes were responsible for which traits and diseases, scientists determined that Tay-Sachs disease was caused by damage to chromosome 15. By identifying the specific gene that was responsible, they were able to replace the old enzyme analysis test with more accurate DNA testing. So now that scientists were able to read people's DNA, this meant that they potentially could identify which genes were responsible for which diseases, which meant that down the line, we were able to identify many more diseases in people's genetics than they were previously. And this is really cool, but it poses a question of how much is too much? At what point do we start coming back to the old problem of the stress and anxiety attached to knowing one's genetic status? And could this potentially turn into eugenics with a capital E? So let me tell you a little more about Dor Yeshorim, and we'll see how they approach this question. Rabbi Ekstein collaborated with a researcher at Fordham University named Dr. Barish Rubin to find the gene that was responsible for another hereditary disease known as family dysautonomia. This disease is similar to Tay-Sachs in that it also causes severe disability, and one of the notable symptoms of this disease is that the person afflicted can't feel any pain. The gene that was responsible for this disease, family dysautonomia, was not yet identified, which meant that Dor Yeshorim couldn't perform screening tests to find out if people were carriers and prevent them. And so here's a video of Dr. Rubin explaining the experience that he had collaborating with Rabbi Ekstein.
In the summer of 1999, I was approached by Rabbi Ekstein of Dor Yeshorim, who asked me if I would help him find the genetic cause of familial dysautonomia. And I went through the literature at that time, and I saw that there were some top groups that were working on familial dysautonomia and trying to figure out the genetic cause, and I called them back and I said, there's nothing that I have that the other groups do not have, so I have nothing to provide you that will not be provided by the general scientific community. In almost a year later, in the summer of 2000, he contacted me again and he said, nothing has been accomplished. More children have been born with familial dysautonomia in the population. It is tearing apart families. And so what I said to Rabbi Ekstein is, I have a group of students that are available this summer, and I will spend the summer working to try to find the genetic cause of familial dysautonomia. And he provided me the various reagents that I needed in order to do this, and Baruch Hashem, in a 6 to 8 week period of time, we identified the mutation for familial dysautonomia.
Dr. Rubin and his team found that the gene responsible was on chromosome 9, and this meant that they could now screen for it just like Tay-Sachs or any other hereditary disease. Today, Dor Yeshorim's standard panel screens for over 50 diseases, including cystic fibrosis, which is one of the most common hereditary diseases in the world. And in 2015, Dor Yeshorim also began to screen people of Sephardic backgrounds who are also affected by similar diseases like Ashkenazi Jews or anyone else in the world, although they're affected at a different rate. And this was also endorsed by leading rabbis in the Sephardic world, like Rabbi Yosef. Dor Yeshorim screens for a lot of genetic diseases so long as it doesn't come at a psychological cost or social cost to their customer. What this means in practice is that not only are they operating within halacha and the Shidduch system, but they also follow their own guidelines, which differ from other Jewish genetic screening organizations. Most notably is their commitment to confidentiality, which means that they will not tell the customer what their genetic status is, and they will also not perform a genetic screening if you've gone and done it somewhere else beforehand. In general, in our society, people feel that they have a right to know their medical information. But in the case of Dor Yeshorim, Rabbi Ekstein argues that since marriages are very dependent on a family's reputation, more so than in the secular world, that this takes precedence and is more of a consideration. And so in his opinion, he feels that it's the right thing to do to withhold that information from the customer. As he put it, there's a difference between the right to know and the right to remain sane. For Jewish people who are Orthodox but don't fit exactly into the subculture of Hasidish or Yeshivish, also do genetic screening, but not through Dor Yeshorim, since they don't necessarily date in the Shidduch system, and very often they would like to know their genetic status. For example, there's this web series called Soon by You, and it depicts what dating looks like in the modern Orthodox community, and in one of their episodes, there's this plotline dedicated to the topic of genetic screening. But the company that they use is called JScreen.
JScreen is, they do genetic testing, like screening your genes. It's so people can plan for healthy kids. You'll get to find out if you're a carrier for genetic diseases, and there'll be snacks. I gotta go.
JScreen checks for a much wider panel of over 250 diseases, and they provide all the information which allows the individual to make their own decision regarding marriage and pregnancy. And this is in contrast to Dor Yeshorim, who only screens for a fifth of the diseases, and they do not disclose the details. The guidelines that Dor Yeshorim follows is that they only screen for debilitating recessive genetic disorders that are common in the Jewish population and are avoidable if both parents are not carriers. And according to Rabbi Ekstein, it's this guideline that makes sure that he's on the right side of bioethical questions, as he told Mishpacha magazine that we are not looking for the perfect gene pool. This comment is clearly referencing the critique of eugenics, but it also makes me think of a quote from author Christine Rosen, who wrote about the topic of eugenics, and I want to share with you the quote. The question is no longer whether we will practice eugenics. We already do. The question is which form of eugenics will we tolerate and how much will we allow the practice of eugenics to expand? Not all eugenic practices are equal, and often the same practices can have very different meanings when pursued in a different spirit or governed by a different moral purpose. Perhaps some forms of eugenics are sacred and some profane. As we reflect on the story of Rabbi Ekstein, we can see the true meaning behind these words. Here's someone who escapes the horrors of World War II as a child, only then to face his own personal tragedy with 4 of his own children, and then leverages that to create an organization which prevents that disease from other people in his own community. In fact, in 2008, the director of pediatrics at Kingsbrook Medical Center, named Dr. Ho Chin Chen, wrote to Rabbi Ekstein the following: "Through your aggressive genetic testing program to prevent this serious medical problem, we have eliminated this disease. Our last Tay-Sachs patient passed away 5 years ago, and there has been no admissions since." And although Tay-Sachs disease affects other populations besides Ashkenazi Jews, due to the efforts of Rabbi Ekstein and this organization, they've been able to essentially eliminate this disease from the Orthodox Jewish community. To me, the big takeaway from this story is that the same information that was once used to support a racist ideology that led to the slaughter of millions of people could also be used to ensure that people have healthy children and strengthen the very same group of people that were once threatened by the study of their genetics. It makes me realize that as people, we have the power to take something terrible like a tragedy and turn it into something powerful to help others. And in that sense, I guess I agree with the anonymous Space Yaakov girls, because that is something worth singing about. If you're still watching, I want to thank you for being here to the end of this video. There is a lot to be said about Jewish genetics, but in this video, I really tried to just focus in on Dor Yeshorim, their story, and the relevant science behind it. And it goes without saying that I am no bioethicist, so take everything here with a grain of salt, and it's all filtered through my opinion and my experiences. But if you'd like to learn more, I recommend checking out Dor Yeshorim's website. They have a lot of information there about their history and their accomplishments. And if you'd like to learn more about the science I mentioned in this video, there are some articles and videos linked beneath this video that I recommend you go check out. This video was a little different than the other videos I've done before, but in general on this channel, we focus on moments in Jewish history and also central struggles of what it means to be Jewish, and very often I do that by looking at movies. And so if that sounds interesting to you, then you, my friend, you're in the right place. My name is David, and welcome to Yiddishkeit.